I'm gonna hope and pray that this is actually picking up my audio, because I'm not gonna be here the next 2 days, and I want you guys to have something to reference while I'm gone. So, we're gonna do. Let's just call this tutorial. Okay. Okay. So there's a few things that are mentioned in the written instructions that I've given you. Okay, so the first thing is try to go online, set up communication, properties, select the first COM port. Oh, I don't like that I only have one COM port. That's super annoying. So my guess is that if I try and connect, it's going to fail. And what do you know? It's angry. It's angry at me. Okay, so it's going to tell me I need to close it. I'll close it. Okay, so let me open my PLC IDE again. All right, so this is important because this happens pretty regularly, that people are not able to connect to the PLC. Okay, for various reasons. Okay, so let me just open that same file again. Whenever that happens, so if you just can't connect to it to start with, or if you keep getting like a red error down here, or even if it says connected, but there's a blue bar here that says like no code or something like that, if you just can't get your code onto it, here's what I do. Go to the Resources tab, double click on the Opta, and that should bring up the Opta configuration window in the center of your screen. Okay, so just say that again, Resources on the bottom left, double click on Opta, and then that'll bring you here. Another thing I keep seeing people run into is, for one reason or another, they're either missing their Resources tab or their Project tab here. The way you get that back up is go to View, Tool Windows, make sure Project is selected, make sure Resources is selected, and what it might do, so if I unselect, deselect, unselect, click Resources, what it might do is it'll pull up as just like a window like this. Okay, you can drag and drop to either, I could put it on the left side of my screen, I can put it on the top. What I like to do is make sure Project and Resources are combined here, so I can just drag and drop one over the other, and now I have them as just tabs on the left, okay, because I use those a lot. Anyway, we're going to go to Resources, double click on Opta, select the lowest COM port. So for me, I only have one, which is insane. I don't know why that is. But then you're going to download the reinitialization sketch. Okay, so this is my like fix whatever is wrong with my PLC that's not allowing me to connect program. Okay, so I will download this, and sometimes this takes a minute. Okay, typically in my experience, whenever you're having issues connecting, once you actually get connected for the first time, every subsequent time you connect to the PLC or download new code, it goes a lot faster and smoother. But for some reason, the first go at it is always just awful. Okay, any jokes? Cameron, I know you've got a joke. Yeah,
It was a fun trip yesterday. That's my joke.
it's good. Hmm, hmm. Well, what are you guys doing? What you got, Isaac?
We walked into a bar.
You'll never see me in a bar, but okay. Oh, okay, yeah. Say it again. Say it again. That's good. That's good. So one of my favorite comedians is Stephen Wright. And he just would do like an hour of one-liners. So I'll say some of my favorite of his. One is I used to work at a factory where they made fire hydrants. You couldn't park anywhere near the place. Um, he said, what is it? Um, uh, I got a parking ticket and I went to court and I pleaded insanity. And I said, Your Honor, why would anyone in their right mind park in the passing lane? Now, perhaps my favorite. Um, hold on. Let me see if I can remember right. No, this is actually a Dimitri Martin joke. He says, I bought a cactus, and a week later, it died. And I was really sad because I thought to myself, man, I'm less nurturing than the desert.
Oh,
Oh, hey, I'm on camera. I didn't know that.
he had given it too much water. Oh.
Okay. Oh, we're good. We're good, guys. We're back in business. Here we go. Okay. So if I double click on this, you'll see now I have two COM ports. This is great. So I'm gonna see if I can connect to the first one. Click OK. Okay, we'll see if I can connect. I'm connected. This is great. This is good news, guys. No code. No dice. Okay. Um, okay, so now that I'm connected, I need to go to project. Right click on my tutorial project, add new program. LD stands for ladder. So I'm going to just call this my ladder. You always, always, always have to assign it to a task. I just always assign it to fast. We're not going to be doing enough with the programs to actually need different task folders. But click OK. All right. Here is the reason that it is called ladder logic. You will see that this resembles something of a ladder. Crazy, right? Okay, so you got rungs on a ladder, right? Inputs are on the left. Okay, this is a normally open contact, which means if this happens, do this. Okay, where this is a coil, which is an output. Okay, now you can do all kinds of awesome stuff with ladder logic. Okay, so you can do really simple or even complex Boolean logic. Okay, where I can say if this happens and this happens, do this. Okay, I can also say if this happens or this happens, do this. I can say if this happens and this does not happen, that's what that means, that little bar in the middle. When you double click, you can say negate. Okay, if this happens and this doesn't happen, or this happens, do this thing. Okay, or you can also add multiple coils and turn multiple things on in the same line. All right, pretty straightforward, guys, right? Now, what happens with ladder logic is it executes the program within milliseconds, but it does it from top to bottom. Okay, and that's probably not going to be super important for anything we're doing. But if you are referencing things that are functioning on a very fast level, and this changes down here, but it's called up here, then it might not actually execute immediately. It might execute the next scan cycle. Okay, so the PLC is constantly scanning the ladder logic from top to bottom in milliseconds, and so just be aware. Okay, now I can do a few different things with the inputs on my PLC. Anything that is physically a part of your PLC, like we talked about. So the button, the digital inputs, relay outputs, LEDs, all of that is going to be set up under the Resources tab, Local I/O Programming. All right, forever and always, I just call this in 1, in 2, in 3, in 4, in 5, in 6, in 7, in 8, and we're good. Relay outputs, I call out 1, out 2, out 3, out 4. Okay, I'm going to ask that forever and always you just use these conventions. Okay. Now, I will say, though, when we get into the analog expansion, what you might need to do is say that this is 1 out 1. Okay, meaning that this is my my first, look up here. So like this is my first module. Okay, and then if I'm using outputs on my second module, I would call that like 2 out 1. Okay, or something like this. Anyway, I'm just going to call it 1 out 1 since we're only using one module right now. LED outputs, we're going to say LED 1, LED 2, LED 3, LED 4, and we're good. Okay, now, oh, and then last thing, we're not going to use the red, green, blue, but I do need to use the button. Okay, what I would like you guys to do in every program from here on out is I'm actually going to have you create another ladder logic program, and we are going to call this IO IO map. Okay, and all we're gonna do here is just say that. Actually, I'm gonna change this. We're gonna call it LED map. How's about that? LED map. Okay, and what this is gonna do is just ensure that anytime output 1 is on, that turns on LED 1. Okay, and we're going to do this for all 4 of my outputs. Okay, so output 2 should turn on LED 2. Okay, and just to, I'm typing them in, but you can also click on the ellipses and it'll automatically pull up any IO that you've explicitly named. Okay, we'll call it output 3. Needs to turn on LED 3. Okay, and then the very last one is going to be output 4. Should turn on LED 4. All right, so I'm just going to go ahead and save my program real quick, just in case it decides to be angry when I try and download the code. All right, so I'm going to download the code, compile it. Oh, I have 5 errors. I didn't name my outputs. Oh, it's because in my ladder logic, I have a bunch of stuff with question marks. So I'm just going to delete everything out of here and then download the code. Ben, do you have a joke? Anyone excited about Dune 3? Just me? Dune 3?
Oh, yeah.
Okay, so this says cold restart required. Both retain and non-retain variables will be reset. We will continue. So click yes. Error. Oh, okay. So I don't know if anyone's gotten this error before, but what you will see is this. Yes. Yes. It doesn't need my location. Come on. Okay. Okay, so you'll see I have my analog expansion connected. Okay, so it's given me whoa. It's all right, Kellen. So it's given me flack because um, my expansion is connected, but my code does not reflect that I have an expansion. Okay, so this is a really quick fix. So click OK. Go to Resources. Under I/O expansions on the left, double click it, and click Scan. It's saying configuration is not matching. So it's saying that in your project configuration, you do not have an expansion, but it does say that one is detected. So all you have to do is click Apply Detect Config. And then what it does is it adds the expansion that was detected, it adds it to your project. So now you can see in my Resources tab, I've got the expansion tab. I can now name all of these inputs and outputs. Okay, so now I don't need to do anything with that. But what I can do is just go back to my project. I don't need to go here to do this. But I'm going to try and download my code again, and hopefully this time it works. Cold restart required. Sure. And waiting. All right. For some reason, sometimes it does this. It'll say that there's an error, but then if I just connect, okay, so I'm connected, but it says not running. So this is one of those errors where I'll go back to my Resources tab, Opta, and now I'm going to download the reinitialization sketch to my first COM port. I have to disconnect first, so I'll go up here, disconnect, download, click OK. If everything goes well, I'll only have to download it to the first COM port, and then it'll let me download my code. If it doesn't go well, then I will have to download it to both COM ports. Why in the world this has two COM ports? No idea. I don't know what the two different COM ports purposes serve. But boy, it does give some trouble. I will say if you buy an actual like industry standard PLC, okay, this is a pretty new product. I think it's more for educational purposes. But if you were to buy like an Allen Bradley PLC, it would work really well the first time. Okay, didn't like that COM port. I'm gonna go ahead and try the second COM port. Yes. Yes. Grace gave me this wonderful pin here. He's got dynamite. I don't know if that's like threatening or what, but did you guys know that the guy who invented dynamite is Mr. Nobel, where we get the Nobel Peace Prize? Okay, this is not cool. Oh, there we go. Okay, so I didn't actually need to download the initialization sketch. All right, hey guys, listen. So one thing that I'll try if I'm connected but it's not running my code is I'll try a warm restart, which is the green button here. And then if that doesn't work, sometimes I'll try to reboot, and then you'll have to like reconnect to it. It's a whole ordeal. But I try to, in order, connect, download. If download doesn't work, I try a warm restart, and then reboot target if warm restart doesn't work. Anyway, we're good now. So my code is on there. So now in my ladder logic program, I'm going to do this. I do have to disconnect. Go to scheme, object, new, coil. Oh, well, I guess I have to add a rung first. I'm going to say new at the top. So I'm going to say if button is turned on, go ahead and turn on output 1. Okay, pretty simple. But now I'm going to connect. Okay, this yellow bar here says diff code. That's completely fine. All that means is that the code in my project is different from the code in the PLC. So I'll click download, compile. So something else that's important, this would be a great quiz question, is the reason the word here is download is because whenever you're in the PLC IDE, so whenever you're using the software functions as the monitor for the PLC. So the PLC is the computer, the IDE is the monitor, and so you're saying I want to download what's on my monitor to my computer, the PLC. Okay, so that's why it's download instead of upload, which is why if you're working as a controls engineer, you want to be very cautious when you click download, because if you click download, you could change the code on a $1 million machine. I've definitely done this before. And then production's down for like a couple hours because you got to go get the old code from a hard drive or something. It's a nightmare. Okay. So it's saying not running. Let's try a warm restart, see if that fixes it. It fixed it. Okay, so now check this out. I'll go here. So I had it set up to where when I click the button, output 1 should come on. So two things should happen. One, you should hear my relay click. But because I said that anytime output 1 is on, it should turn the LED on. The LED should also come on. So here we go. So you hear both a click and the LED comes on. Can you guys hear the click? So that's the relay. So that comes from this right here. Okay, so this coil is creating magnetic field, and that switch is actually physically closing inside the PLC. That relay is closing. Okay, so friendly reminder. Other things we need to talk about are function. Well, yeah. So if I wanted to, I could use live debug mode. This is a pro gamer move. If I click live debug mode, I can actually see in real time what is on and off in my code. Okay, so rather than switching to the camera, I can click the button and you'll see it turns blue, and my output 1 turns blue as well. You guys see that? Okay, that's super handy for as a controls engineer, rather than getting on the factory floor. If I've got an Ethernet port in my office and I can connect to the machine remotely, I can go live and actually see what's on and off on the machine, rather than me putting on my steel-toed boots, putting my safety glasses on, putting on hearing protection, and getting out on the factory floor. I can just see from my office what's going on. Pretty useful. That looks precarious. Okay. Other things I can do though are this. It's okay. So I showed you can create local variables. Okay, I do have to go offline first. Okay, so this allows me to create things that can be used in the logic that are not tied to anything physical. Okay, so I could say bit, I could just call this bit, okay? And it's a Boolean, and then I can just use that for whatever I want in my logic. Okay, so I could say if the button is pressed, turn bit on. Okay, pretty simple, but that's going to come in handy. In fact, that's going to come so much in handy that what I'm going to do is I'm actually going to have this be an array. So I'm going to have this be 1 to 16. Click OK. And now this is an array, okay, which means that I actually have 16 of these bits. Okay, so rather than turn output 1 on, I'm going to find bit, and I think it would be bit.1. Okay, and if I connect and download my code, if it doesn't give me any errors, missing index. Okay, so I did it wrong. I think maybe it's bit brackets 1. Okay, yep, this works. Okay, again, I don't know why it keeps doing that, but I'll do a warm restart again. Okay, so now if I click the button, bit 1 should turn on. Yep. Okay, this is really useful. Arrays are incredibly useful because this keeps me from creating bit 1, bit 2, bit 3 manually. Okay, I can just call it a 16-bit array, and then automatically I have 16 unique bits that I can use for testing purposes. Can you get a thumbs up if this makes sense? Okay, I know this is not the most thrilling stuff. We're going to get to building our electrical enclosure here in a minute. But I want to make sure everyone's set up for success. And there's no loose ends. Okay, the only other things that we need to talk about in the program are, I know some of you got experience with this, but that would be function block diagrams. Okay, so if you go to Object, New, Block, okay, you have a few different things. You have operators. So this is anything addition, anything mathematical. So I can use addition, division, equals, greater than or equal to, greater than, less than or equal to, all that good stuff. Okay, so if I wanted to, I could say, actually, I'm not going to use those quite yet. We're going to say function blocks, unselect operators. I'm going to use the timer off, timer on is TON. And you do have to name this. I'll call it TON1. Okay, so this is my input. So whenever the button's pressed, this activates my timer. From here, I need to give it a preset time. So this is always in milliseconds. So right now, if the button is pressed, it's going to count up to 5 seconds or 5,000 milliseconds, and then it will turn bit 1 on. So let me connect, download the code. Okay, what? There we go. Okay, warm restart. All right, if I go to live debug mode, you'll see ET, that's elapsed time, not extraterrestrial. Elapsed time. Okay, so what you'll see is right now it's 0, but if I press the button, it starts counting up to 5 in milliseconds. Then once it reaches 5,000, bit 1 comes on. Make sense? Okay, and then TOF is essentially the same thing, but it turns something off. Okay, so it counts up to some number, and then when it reaches that number, it should turn this bit off. Okay, would you like me to show you, or do you just take my word for it? Okay, cool. Trust me, love that. Okay, the other thing is the counters. So rather than go to that every time, I'm going to find FBD bar. That's my function block diagram. So now I can just click new block instead of going to scheme, all that nonsense. So I'm going to find CTU, and we'll call this CTU1. Okay, this is really similar, but instead of starting a timer, anytime this button is pressed, it's going to count up. And then once my count value reaches my preset value, then that turns Q on. So I'm just going to set my preset value to 5. And then reset would be, you can hook it up to a variable. So I could hook it up to input 1. So whenever input 1 is on, that resets my count value. Okay. So let's just go ahead and download the code. Man, it keeps giving me the business, guys. Here we go. All right, so now if I go online, if I click the button, my count value goes to 1. If I click it again, it goes to 2. Again, 3, 4, 5. Now that I'm at 5, bit 1 is on. And as long as my count value is over the preset value, then your bit's going to stay on, okay? So I can keep doing that. Now, if I wanted to reset it, I could do this. I could hook it up to a physical input, or I could say this. I'm going to use a function block diagram and use my operator. I'm going to use a greater than, and I'm going to say this. This is really important, guys. This is going to help you down the road. So all of these bits, so like the R, the reset bit, PV, CV, Q, those are actual variables that I can recall. And the way I can do that is I can say if CTU1.CV is greater than CTU1.PV. So if my count value is greater than my preset value, so once this goes above 5, I want to turn on bit 2. And then I can connect my reset bit to bit 2. Okay, now I can connect, download my code. Okay, we're almost done, guys, I promise. Connect. Warm restart. I don't know why I'm having to jump through all these hoops just to get connected, but I'm going to go live. And so I'll do this again. I'll press my button 5 times. 1, 2, 3, 4, 5. Okay, bit 1 is on. And you'll see here, 5 is not greater than 5, so bit 2 is still false. But if I press it one more time, then that will be true. Okay, but it might happen so fast you might not even see it. Okay, because the moment this goes to 6, that'll go to true, but then this will reset and this will go to 0, so 0 is not greater than 5. So I don't even know if we'll see it go true. Yeah, you didn't even see it happen. But the moment I press the button, it reset. So that's how you use function block diagrams, or function blocks. Any questions? Okay, and I could use a CTD, and that's the same thing. It's just it counts down from a preset value. Okay. Only other thing is you need to know how non-Boolean types work. So if I go offline, so rather than set my preset to 5, just the number 5, I could insert, we could say var, we'll just say variable. And I'm going to make this a dint. That stands for double integer. So I think you can count up to like 28,000 or something crazy. I don't remember what the number is. But instead of it being a Boolean that can only be 0 or 1, I can actually give this an initial value, and we'll call it 5. Okay, and then instead of just setting my preset value to 5, I can just call it variable, and that'll do the same thing. Okay, but this allows me to actually change the variable. So maybe I have different programs tied to my switch that say if switch 1 is on, set variable to 10. If switch 2 is on, set variable to 15. Okay, so I have different options for what my preset value is. Okay, and if I wanted to, I could also make this an array where this is 1 to 16. Whoa. Okay, so and if I wanted to, I could call this variable 1. Okay, so now I have 16 different variables that I can use. All right, any questions? Okay, it is 9 o'clock. I'm going to stop my broadcast.